Imagine you're a scientist, sitting in a quiet control room, and suddenly your computer detects a signal from deep space that's so strange, so perfectly structured, that for a moment it looks like intelligence. And then, it disappears. In this video, I'm going to talk about such signals. Over the last decades, we've detected signals that shouldn't exist. Signals that were too powerful, too fast, too regular, or too random in the wrong way. Some were traced to weird cosmic events. Some were traced to human technology. And some, we still don't know. Today, we are going through the most mysterious signals ever detected from space, and what scientists think they really are. Space is full of extreme objects that produce radio waves, gamma rays, X-rays, and bursts of energy that can outshine entire galaxies. And the scary part is, sometimes we detect something that doesn't match any known pattern. Let's start with the most famous one. In 1977, a radio telescope called Big Ear in Ohio detected a strong radio signal. It lasted for 72 seconds, and it came from the direction of the constellation Sagittarius. What made it special? It wasn't weak background noise. It wasn't random static. It was strong, clean, and narrowband, meaning it was concentrated around a specific frequency. The astronomer who saw it, Jerry Eman, was so shocked that he circled the printout and wrote one word: "Wow." And that's how it got its name. Why is it still a mystery? Because it never happened again. Scientists tried to detect it again. They pointed telescopes at the same region. Nothing. To this day, nobody knows what caused it. The leading explanations: a rare natural radio source, a passing comet emitting hydrogen signals, or something else. The comet theory is popular, but not everyone agrees. And here's the key detail. The WOW signal was detected only once, with a shape that looked like something passing through the telescope's field of view, like a distant source slowly moving across. Now we move into the modern era. Fast radio bursts are one of the biggest mysteries in astronomy. They're exactly what they sound like: insanely powerful radio pulses that last for milliseconds. But in that tiny moment, an FRB can release more energy in radio waves than the sun produces in days. And here's the weird part. Many FRBs come from extremely far away, other galaxies. Meaning, something out there is producing a radio flash so powerful that we can detect it across billions of light years. How were FRBs discovered? The first one was found in 2007, hidden inside old telescope data. At first, scientists thought it was a glitch, interference, or a mistake. But then more were detected. And suddenly it became clear: FRBs are real. The problem? We still don't fully know what causes them. The most common theories include magnetars, supermagnetic neutron stars, collapsing stars, neutron-star collisions, black hole-related events, exotic plasma phenomena. But even magnetars don't explain every FRB, because most FRBs are one-time events. A burst happens, then it's gone forever. But in 2012, scientists found one that repeats. Its name is FRB 121102. It comes from a dwarf galaxy about 3 billion light-years away. And it doesn't just repeat randomly. Sometimes it bursts multiple times in a short period. Then it goes silent for weeks. Then it comes back. Why is that insane? Because it means the source is not a one-time explosion. It's something that can survive and keep producing these pulses. And here's another detail that made scientists freak out. The bursts were highly polarized, meaning the radio waves were twisted by a strong magnetic field. So whatever is producing it is sitting in an extreme environment, possibly near a black hole, a dense nebula, or inside a super-energetic star remnant. FRB 121102 is still one of the most studied repeating signals in space, and it's still not fully understood. Now here's a story that sounds like science fiction. In 1967, a graduate student named Jocelyn Bell Burnell was analyzing radio telescope data, and she noticed something weird. A repeating signal. A pulse. Perfectly timed. It was like a cosmic lighthouse. At first, scientists didn't know what it was, and because it was so regular, they jokingly labeled it LGM-1, which stands for Little Green Men. Yes, the alien joke was real. What was it actually? A pulsar. A pulsar is a neutron star, the ultra-dense core of a dead star, spinning extremely fast and blasting radio beams from its poles. As it spins, the beam sweeps across space. And if Earth is in the path, we detect it as a pulse, like a clock. Some pulsars are so stable that they're more accurate than atomic clocks. Why this matters? This moment is important because it shows something. Space can naturally create signals that look artificial. Perfect timing doesn't automatically mean intelligence. It means the universe can be unbelievably weird. Now let's talk about something much more recent. In 2020, scientists using the Parkes radio telescope in Australia detected a signal coming from the direction of Proxima Centauri. That's the closest star to our solar system, only about 4.2 light-years away. The signal was named BLC-1, which stands for Breakthrough Listen Candidate 1. Why did it look suspicious? Because it was narrow-band, stable, and seemed to drift in frequency the way a signal would if it came from a moving planet. For a moment, it looked like a serious candidate. So what happened? After deeper analysis, scientists concluded it was most likely human interference, probably from Earth-based technology bouncing in a weird way. Even though it appeared to come from Proxima Centauri, it was likely a false alarm. But here's the scary part. It shows how difficult this is. Even with the best modern equipment, we can still be fooled. And if a real artificial signal exists out there, we might accidentally dismiss it. Now we are getting into the truly disturbing category. Signals that don't just come from space. They come from objects that shouldn't even be possible. Astronomers have detected stars that produce signals that look like a heartbeat, repeating patterns of brightening and dimming. One famous example is a category called heartbeat stars. What causes it? It's usually two stars orbiting each other in a very stretched, elliptical orbit. When they pass close, their gravity distorts each other. That distortion changes brightness in a repeating pattern. So why is this in a mysterious signals video? Because some heartbeat-like signals don't match the simple binary star explanation. In a few cases, the timing is weird. The amplitude changes, and the pattern looks engineered. Scientists don't claim aliens, but they do admit that some star systems are producing repeating patterns that we don't fully model yet. Now we get to one of the most famous mystery signals in modern astronomy. Tabby's star, also called KIC 846-2852, was discovered using NASA's Kepler telescope. Kepler's job was to find exoplanets by watching stars dim. Because when a planet passes in front of a star, the star dims a little. Usually the dip is small, regular, and predictable. But Tabby's star did something completely different. What happened? It dimmed randomly, sometimes by 1%, 5%, 10%, even up to 22%. That is insane. For comparison, a Jupiter-sized planet causes about a 1% dip. So for Tabby's star to dim by 22%, something huge would need to pass in front of it. Why was it creepy? Because the dips were irregular, chaotic, and extremely deep. At one point, the alien megastructure hypothesis became popular. The idea was, maybe an advanced civilization is building something massive around the star, like a Dyson swarm. What do scientists think now? The most accepted explanation is dust clouds, debris, or some complex combination of material orbiting the star. But here's the key. Even today, Tabby's star is still weird. It forced scientists to admit something uncomfortable. We assumed star dimming patterns would always be simple, but the universe is capable of making patterns that look artificial. Radio signals are only one category. The universe also sends signals in X-rays, gamma rays, ultraviolet, and some of the strangest signals ever detected are X-ray pulses that repeat like a clock. One example is X-ray pulsars, neutron stars emitting X-ray beams. That part is understood. But here's the mystery. Some X-ray sources pulse with periods that don't match typical pulsar behavior, and some change their pulse rate over time in a way that suggests unstable rotation, strange magnetic interactions, or something orbiting them. The unsettling part. X-ray signals often come from extreme environments. Black holes, neutron stars, supernova remnants, meaning we are watching physics under conditions we cannot reproduce on Earth. So sometimes the signal isn't mysterious because it's unknown. It's mysterious because it's testing the limits of what we think matter can do. Now this one is less famous, but honestly more disturbing. Astronomers have detected a radio glow in the sky called the cosmic radio background. Basically, when you point radio telescopes into space, you expect some radiation from galaxies, some from gas, some from known sources, but the background radio signal is stronger than expected. So what's the mystery? We don't know what's producing all of it. There seems to be extra radio emission. It's like the universe has an additional layer of radio noise. Possible explanations: tons of faint galaxies we haven't detected, unknown cosmic particle processes, early universe effects. But right now, it's still not fully solved. And the creepy part is, this isn't one signal. It's like a constant whisper across the entire sky. We already talked about FRBs, but we need to mention the original one. The first fast radio burst was discovered in old data and is called the Lorimer burst. It was so powerful and so strange that scientists initially doubted it was real, because it looked like something impossible. A super short signal, extremely strong, from extremely far away. What makes it still mysterious? It's not that we don't believe it anymore. It's that we still don't know if it was a normal FRB, something even rarer, or an entirely different type of event, because the first one was detected before we even knew FRBs existed. So the Lorimer burst is basically the first clue in a mystery that science is still solving. Okay, quick story, because it's legendary. In the early days of FRB research, astronomers detected signals that looked like FRBs. They were called peritons. Scientists were confused because they seemed real, but also suspicious. The twist: eventually, researchers found the source. A microwave oven. Not space. A literal microwave. When someone opened the microwave door early, it created a burst of radio waves that the telescope picked up. Why this matters? Because it shows how fragile this field is. We are trying to detect millisecond signals from billions of light years away, while surrounded by human technology that can fake them. And now we are going into the scariest category: signals that might be coming from the darkest objects in the universe, and signals that we still cannot explain even with modern physics. Now we get to one of the newest mysteries. Astronomers recently discovered an object with a name that sounds like a password: GPM J183910. And what it does is weird. It emits radio pulses like a pulsar, but the timing makes no sense. Why? Normal pulsars spin extremely fast. Milliseconds. Seconds. Maybe a few seconds. But this object pulses roughly every 21 minutes. That's not a pulsar. A neutron star spinning that slowly should not be able to generate a strong radio beam. According to classic pulsar models, it should be dead. So what is it? Scientists think it might be a magnetar, a white dwarf pulsar, or an entirely new category of object. This discovery is important because it suggests we might not fully understand how dead stars behave. And if we don't fully understand dead stars, then we don't fully understand a huge part of the signals we receive from space. Magnetars are neutron stars with magnetic fields so strong they basically break your intuition. A magnetar's magnetic field is trillions of times stronger than Earth's. Strong enough to affect atoms. Strong enough to twist the crust of the star. Magnetars are known for producing X-ray flares, gamma-ray bursts, and sometimes radio bursts. And in 2020, something happened that changed everything. Scientists detected an FRB-like burst from a magnetar inside our own galaxy, meaning at least some FRBs can come from magnetars. So what's still mysterious? Because not all FRBs behave like magnetars. Some repeat in patterns. Some don't. Some are polarized in strange ways. Magnetars explain a lot, but not everything. So the FRB mystery is still alive. Okay, now we're going into the category of mysteries that are not just signals, but gravitational effects that behave like a signal. The Great Attractor is a region of space that appears to be pulling our galaxy and thousands of other galaxies toward it. The Milky Way is moving through space at about 600 kilometers per second, towards something. And the weird part is, we can't clearly see what's causing it. Why can't we see it? Because the great attractor lies behind the zone of avoidance, a region blocked by the dust and stars of the Milky Way. So we are basically being pulled towards something that we can't fully observe. What could it be? The leading explanation is a huge concentration of galaxies, massive clusters, and dark matter. But it's still unsettling because this isn't a small mystery. This is a gravitational force affecting millions of galaxies. Now let's go back to pulsars. We said pulsars are like clocks, but sometimes they glitch. A pulsar can suddenly change its rotation speed. It might speed up slightly, then slow down, or show timing noise that shouldn't happen. Why is this weird? Because pulsars are neutron stars. They are basically ultra-dense, extremely stable, and spinning in near-perfect isolation. So why would they suddenly change? The best explanation: starquakes. Neutron stars have a crust, and that crust can crack. When it cracks, the star's rotation can shift. It's like a cosmic earthquake, but not all glitches match the models. Meaning, even neutron stars, objects we've studied for decades, still surprise us. Gamma-ray bursts are the most powerful explosions we know of. They release more energy in seconds than the sun will produce in its entire lifetime. Usually they come from collapsing massive stars, neutron star mergers. But some gamma-ray bursts have properties that don't fit cleanly. For example, weird durations, strange afterglow. We understand the general category, but not the full variety. And gamma-ray bursts matter because they are signals so powerful they can be detected across the entire observable universe. So every time we detect one, we are basically watching the universe doing something extreme. Now here's one of the most unsettling facts in this entire topic. Even if an artificial signal exists, there are many ways we could miss it. Why? Because the signal might be extremely brief. It might repeat only once every few years. It might use a frequency we aren't monitoring. It might be hidden in noise. It might look like interference. It might look like a natural object we already explained. And there's another issue. Our planet is becoming louder in radio noise every year. Satellites, Wi-Fi, military signals, telecommunications. This makes the search harder. So the biggest mystery might not be, is there a signal out there? It might be. Would we even recognize it? So what did we learn from all these mysterious signals? Space isn't quiet. It's filled with bursts, pulses, repeating patterns, flashes, background noise, and cosmic events that look like intelligence until you understand them. Sometimes the mystery is solved, like pulsars. Sometimes it turns out to be human technology, like peritons. And sometimes the signal remains unexplained for decades. And the most important part is this: every time we detect something strange, we're not just collecting data. We are discovering new physics, new objects, new categories of cosmic events. Because the universe is always sending messages. The real question is, which ones are we still not smart enough to read? If you enjoyed this video, you'll love the next one. Subscribe for more science explained simply. Write in the comments what you would like to hear about. Have a good day.